So good evening, welcome to my channel. Tonight we will be discussing Euler paths and Euler circuits. So what are Euler paths and Euler circuits? So an Euler path is a path that uses every edge in a graph with no repeats. So an Euler circuit is a circuit that uses every edge in a graph with no repeats. So what is the difference between the two? The difference between path and a circuit is that a circuit returns to its normal position. Remember that a circuit returns to its normal position. So I'll give an example of what the graph of an Euler path or an Euler circuit is. So let's look at here. This is an example of an Euler path. Why is it an example of an Euler path? We said a while ago that a path that uses every edge in a graph with no repeats. What is the difference again of an Euler path and Euler circuit? Euler circuit is a circuit that goes back to its normal position, while an Euler path does not go back to its position. So how do we solve this? How do we prove that this one is an Euler path? For example, this is our starting position. This is our starting position, and we will move until there will be no edge that is available. First, we can go here. Next, go here. Next, go here, or we can go here. After that, we can go here. Lastly, we can go here. So we can put the numbering. So this is the first, this one is second, third, fourth, fifth. You can see letter D. This vertex D is the ending position or the terminal position. Terminal point can be terminal vertex. Can name it starting position or vertex. Okay, so as shown in the graph and in our solution, this is an Euler path. So an example of an Euler circuit is like this. So how do we prove if it is an Euler circuit or not? For example, we're going to start here. This is our starting position or vertex start. I just name it start. So the solution will be, first I can go here and name it number 1. Then after that, go here, number 2. To that, C to D, number 3, 4, B to E, D to B, 5th, B to D again, 5th, D next, D to E, 7, final, E to B. E to B. Okay. So as shown, we already know that this is an Euler circuit because we start and ended at point B. So this is also our ending point. Okay. So let's now move to the next slide. So an Euler path and an Euler circuit theorem. So a graph will contain an Euler path if it contains at most 2 vertices of odd degree. Next, a graph will contain an Euler circuit if all vertices have even degree. So remember, an Euler path at most 2 vertices of odd degree. Next, an Euler circuit if all vertices have even degree. So let's have an example. Given this figure, is this an Euler path or an Euler circuit? You can pause the video to solve the problem. So now we can now count the number of degree of each vertices. So let's start with A. A has how many? 1, 2, 3. So A has 3 degree or 3 vertices. Next, let's go to B. B has how many? 1, 2, 3, 4. B, 4 vertices. Next, let's go to D. D has how many? 1, 2, 3, 3 vertices. What I mean by vertices is the degree of vertices, okay? So next, D. So next, after D, let's go to C. How many? 1, 2, 3, 4. C, 4 vertices. Lastly, let's look at E. How many? 1, 2, 3, 4, 5, 6. So how many? So what is the theorem a while ago? A graph will contain an Euler path if it contains at most 2 vertices of odd degree. So again, at 2 vertices of odd degree. Again, I repeat, 3, this number are the number of degrees of vertices. Number of degree or degrees of vertices. Sorry for my bad penmanship. So okay, so now we can see that this one is an Euler path. Why? Because we can see that vertex A and vertex D have an odd degree of 3 vertices. Okay? So let's now move to the next example. So is this an Euler path or an Euler circuit? So you can pause the video to solve the problem. So now let's start with A. How many degree of vertices are there in A? 1, 2, 3, 4. There are 4 degrees. I'll just write 4 degree. Next, let's go to letter B. How many degrees for letter B? 1, 2, 3, 4. So 4 degrees also. Next, letter C. How many degrees for letter C? 1, 2, 3, 4. Next, letter D. So, okay, how many? 1, 2, 3, 4. D. 4 degrees. Lastly, letter E. 1, 2, 3, 4, 5, and 6. So 6 degrees. We can see that all of the numbers, all of the degree are all even. We can see 4, 4, 4, 4, and 6 are all even. So we can conclude that this graph is an Euler circuit. Okay? So now we have fully understand the difference between an Euler path and an Euler circuit. In the next video, I will be discussing Hamiltonian path and Hamiltonian circuit. I hope you understand this lesson. Thank you.